Okay, guys, let's try this warm-up. Number 1, find all the values of c that make the equation have only one solution. And then number 2, write a quadratic equation that fits the data points. So go ahead and hit pause on the video and wait till you are ready to check your answers on the warm-up. And when you are ready to check your answers on the warm-up, press play. Whoops. Well, my pen went a little nuts. Okay, let's look at the first one. So if we move the c over, and then we get it to where we could have just one solution. What we want is for this to be a perfect square trinomial. And when we look at this, when we take half of this, and we're trying to write it as a perfect square trinomial, we want this to be 25. So we need this to equal 25. So c would have to be negative 25. On the second one, if we want this to be written as a perfect square trinomial, it would look like this. So, square root, square root. So what did we take half of? Well, we took half of 16, but the 2 is there. So in this case, this would have to be 8. And I said find C, and then I wrote B here. Hopefully you found B on this one. All right, let's take a look at the next one. This is a nice one because this gives us a 0, 3. This is our y-intercept. So when we know when we go to plug it into y equals ax squared plus bx plus c, this last one is our c. So we've really already found c. So let's go ahead and plug these in. We'll plug in 4 for y and 1 for x. Okay, now we'll do our second one. We'll plug in 13 for y and negative 2 for x. And then in the last one, if you wanted, you could plug in 0 for your x and 3 for your y. You don't have to because we know what's going to happen. We're just going to be left with 3 is equal to c. Now if we simplify the other two, we get 4 equals a plus b, and 13 is equal to 4a, plus c, 4a minus 2b plus c. Well, we've already determined the value of c is 3, so we can take and plug 3 in for c. So where the c's were, it is now 3. And when we move it over, these are the equations we have. 1 equals a plus b, and 10 equals 4a minus 2b. So if we take the first equation and multiply through by 2, multiply both sides through by 2, this gives us 2 is equal to 2a plus 2b. Now my b's will cancel. Oops, marked right through it. Let's try that again. And when we add these two systems, these two equations, we'll get 12 equals 6a. So a is 2. Now we know a and we know c. We can find b. So I had this equation 1 equals a plus b. Well, if a is 2, then b has to be negative 1. So now we found a, we found b, we found c, we can write the equation. Y equals ax squared, so 2x squared, plus bx, which when we plug in the negative 1 gives us minus x, plus c. And there's the equation that passes through those 3 points. Okay, let's take a look at last night's homework. 2, 3, and 4, you were just supposed to look at the pattern and determine if it's quadratic. So we look at the first difference, and on this one we can stop because the first difference is constant. So we know it's not quadratic because we know that is a linear function when your first difference is constant. In the second one, we do the first difference, and then we do the second difference, and if we notice here, it is not constant. So the second difference is not constant, therefore it is not a quadratic. Let's look at number 4. Our first differences are not the same, but our second differences are. And when our second difference is the same, is constant, then it is a quadratic. So number 4 is a quadratic. Okay, numbers 5, 6, and 7. 5 and 6. These were 2 just like our warm-up, where you plugged in the points and you get the equation at the end. So we're creating the system, we're eliminating a variable, and we're solving. Number 5 was nice because it already gave us the y-intercept. We knew our c. Take a look at this, and if you need to hit pause to correct your homework, you may. I've already posted this on my website, so you can look at that later also. Let's go ahead and take a look at the rest now. Number 6, same thing. You plug in your x, you plug in your y, you already know c. So then you use a system of equations to solve for a and b, and this is our solution. Y equals negative 2x squared plus 3x plus 1. If there's anyone that needs to take a closer look at this one, have them hit pause again. And when you're ready, press play. I'm moving on. All right, on these, okay, we talked about these yesterday. This is when I took the table and I whited out the values we didn't know. If we look, we have this one and this one, so we can find the common difference. So the second difference is negative 2. So the second difference between negative 1 and what's the number? If I subtract 2 from that, I get negative 3. And then I can work my way back up. 0 and negative 3 gives me negative 3. Okay, the next one is quadratic. So we look at those differences. We know that this must be 6. Okay, so if this is 6, then we can get that all these are 6. We're good. So what does this have to be? Well, if this is 6, then this has to be negative 4. And 2 minus 4 is negative 2. Now one way we can get 6 is by looking at the 18, the difference between our last and our first, and there are 3 common differences in between to give us the 6. Okay, 27 works that way, 30 works that way. Take a look at these and see if you have any questions. Okay, once again, these are posted to my website, and if you need to pause for a second, go ahead and do so. And here's the last one where you can see the whole thing. So we're looking, it is quadratic. Since it is quadratic, we can take 3 of those points. Always choose the one that has a 0 in it. It makes your life easy. Plug them in and find the equation. Okay, in today's lesson, we are still doing modeling quadratic equations, but today we're going to do it through the use of technology. This was out of your workbook. It was the same page we worked on yesterday in class. I do believe it's page 351. So if you'd like to work in your workbook with me, go ahead and open the workbook to page 351. Okay. Number 7 says the data table shows the energy of a certain object in joules at a given velocity in meters per second. So energy with respect to velocity. So the energy of a certain object in joules at a given velocity. So we're given the velocity. It is our independent variable. Our energy is our dependent variable. So this table is backwards from what we're used to. This is what we think of as our x, and this is what we think of as our y. Now normally you're given the table in the correct order, but this time you weren't. So you had to read carefully here to discover that. Now it asks us to find a quadratic relationship between the energy and the velocity. And then we're going, once we find that relationship, we find that equation, we're going to answer these questions using that equation. Now, yesterday we did everything by hand. Today we're going to work with more real-world, complicated data, and we're going to use our technology to find that. So take your calculators out also, and we're going to learn how to use our calculators to find this information. Okay, I'm going to work with you on mine. Okay, on the screen, you will see a calculator that looks just like yours, except I've made my faceplate blue. That's the only difference. Now, you probably don't have these graphs on yours like I have on mine. But just so we are all working together, you can clear your graphs if that makes you feel better. We're not even using the graphs just yet. What we're going to do is we're going to use the statistical functions of this calculator. So, how would I do that? Well, I'd go into the Stat button. I've got my cursor on the Stat button now. It's just below the Delete. Please hit Stat. And we are going to enter data onto our calculators. But to make sure everybody's calculator is set up in the same fashion, I would like us to set them up first. Do you see Setup Editor is choice 5? So please hit 5 and then enter. And if you're having trouble following me, what I've done is over here on the right. So we hit Stat, we hit 5, and we hit Enter. So that now we will all have the same setup when we go in to enter our data. So let's hit the Statistics button one more time. And this time we're actually going to enter data. And we do that by hitting Edit. So you can either hit the 1 or you can hit the Enter. And we have data. Now, you may not have data. I have a lot of data. So what I want to do is clear my data. And the way I would clear the data is to hit the up arrow and hit Clear. Do you see how it's now highlighted on L1? When you hit the up arrow, it goes up into this top part, and you can clear all the data by hitting Clear and Enter. And you'll notice it all went away. I want to clear it out of all my table, so I'm going to do the same thing over in L2. I'll arrow over to get into L2. I'll go up and clear the data and hit Enter, and it disappears. I'm going to arrow over to L3. I'm going to clear my data. Oh, I didn't go up, did I? So I have to go up, then hit Clear and Enter, and my data disappears. Okay, what we're going to do is enter our independent variable. In this case, our independent variable is the velocity into L1. And we'll enter our dependent variable into L2. So in that first column, please enter your independent data. 1.5. Enter. 2.5. Enter. 3.5. Enter. 4.5. Enter. I'll give you a moment to catch up with me. Now let's arrow over to L2 and we'll enter our dependent data, which in this case is our energy. So let's enter 4.5. Enter. 12.5. Enter. 24.5. Enter. 40.5. Okay, so hopefully we are all in the statistics mode. We have entered our data in L1 and in L2. And now what we're going to do is to allow our calculator to work for us. So I'm going to clear out the key history here. So we should all be here together. And now what we're going to do is we're going to do quit out of this for a moment. And we're going to hit the statistics, and then we're going to calculate. So I hit second in mode to quit, and then I hit statistics. But this time I'm going to calculate. So I arrow over to calculate. And does everybody see something that looks similar to quadratic? Hopefully you found choice 5. Choice 5 is a quadratic regression. Now you could either hit the number 5, which is what I usually do, or you can go down here to 5 and hit enter. Now we entered our data in L1, and the way we tell that is we do second and 1, and then the rest of our data in L2. So we'll say comma L2 and hit enter. Now, does everybody see it gave us an A, it gave us a B, and it gave us a C? What it has done for us is created the equation for this set of data. It said A was 2, B is 0, C is 0. So when we plug into that AX squared plus BX, X plus C, our equation is in this form, Y equals 2X squared. But since we're dealing with energy and we're dealing with velocity, wouldn't it make sense to use the variables that represent energy and velocity? So we're going to use E for energy is equal to 2 times the velocity squared. Now we have the equation that represents this data. What is the energy of an object with a speed of 5 meters per second? So all we do, we plug in 5. So we get energy is equal to 2 times 5 squared. And this would give us 50, and energy is measured in joules. C asks us, what is the velocity of an object if the energy is 128 joules? So we'll plug 128 in for energy, and we'll solve for velocity. We'll divide by 2, and our velocity would be 8 meters per second. Okay, we're going to do one more example today using the technology, and this one's out of your book. And your homework assignment is also out of your book, so let's go ahead and get that book out. And we're going to open the book to page 519. Page 519 out of your textbook. And we're going to look at this problem together on page 519. Okay, this says gold's closing price each year is shown in the table. So we have the years 2000 to 2010 and the price of gold per ounce for those years. It says Orlando looked carefully at the data table and said it appears to represent a quadratic function. Do you agree? Okay, so if we look at this, do we feel that this might represent a quadratic function? What are ways we could tell? We can look at the second differences. Are the second differences close? If we say yes, then we should try a quadratic model. Now let's go ahead and find a quadratic model for this. And it said use x equals 0 for the year 2000. So here, when I enter my data, this will be 0. Therefore, 2001 would be 1. And this would be 2 all the way up to 10. And then we would enter our price of gold. Now, our year is our independent variable. So they gave us our independent variable in the correct order, what we're used to, independent over dependent. So this is our x, this is our y. So let's go ahead and pull those calculators back out. Let's go back into our statistics. So everybody hit statistics. Let's go back into edit. And we're going to clear that data. So hopefully you remember arrow up, clear, enter. Arrow over. Arrow up, clear, enter. And now we're going to enter our new data. So the years 2000 to 2010, we're going to start 2000 with a 0. So we go 0 to 10. 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now I've entered the years, my independent variable. And then we have our dependent variable, the price of gold. Please enter that into column 2. 273, 277, 343, 417, 436, 513, 636, 837, 870, 1088, 1420. And I always double check my data entry. Okay, I'm going to pause a moment and let everybody catch up. So hopefully you have entered all your data into your calculator. Okay, and now we're going to find the equation for it. So we'll quit out of this. And then we'll hit stat, so second quit mode, which is quit, and then hit stat, arrow over to calculate, quadratic regression, choice 5. We put our data in L1, so second 1, comma, second 2. So L1 was second 1, the comma is right above the 7, L2 is second 2. And hit enter. Okay. Alright, so this one's not as pretty, is it? I'm going to add this one to our other. This is our A, this is our B, this is our C. So we're going to have to do a little bit of approximating here. We're going to say Y is approximately. Let's round to the nearest tenth, and we'll say 11.7 x squared minus 11.9 x plus 295.1. Okay, so now while we're here, I want to show you another way to know that this could be a nice quadratic. We're going to look at our data. And the way we can look at our data on the graph, let's go back to the calculator and we're going to graph this data. Okay, so go back into y equals. If you didn't clear your equations earlier, please clear them now because we're about to plot our data. If you hit second and y equals, we can turn plots on. So second and y equals, and we'll turn on plot 1. Right now, off is highlighted. I'm going to highlight on by hitting enter. Then I'm going to go down to the next one, and I'm going to tell it, ooh, I want this first one, which is a scatter plot. I'm going to hit enter. Now, do you see it's asking me, where did you put your X list? Well, I put mine in L1. So I do second and 1. Where did you put your Y list? Arrow down and hit L2, second 2. And then you get to pick how do you want it to mark the data, the open circles, the little crosses, or the dots. And it doesn't matter what you use. So now we've turned our plots on. But before we hit graph, we want to be able to get a good graph of this data. So now that we've turned all this on, we're going to hit zoom, the zoom button, which is right here, top middle, zoom. And we're going to zoom. If we arrow long way down, we should see zoom stat is choice 9. That zooms in on the statistical data we entered. Do you see what looks like a quadratic curve here? It's not perfect, but it fits it fairly well, doesn't it? Now, if we went back to where we hit stat, and we arrowed over to calc, and we told it we wanted to do a quadratic regression, and we told it, hey, my data's in L1 and L2, and I want an equation to go into Y1. You'd hit one more comma, then do the VARS button, arrow over to YVARS, choose function, and choose 1 for Y1. And then hit enter. Gives us the same thing, but now when we go back and look at our graph, do you see it drew that function it just gave us right through that data? That's a good model of our data. Now, this last part you don't have to do. I'm not requiring that you be able to graph that line in there. I just want you to be able to come up with the equation. All right, that's it for today. If you need to listen to this again, it'll be on my YouTube.